Okay, for lesson 4, we're going to talk about the slope formula, which we started to look at in class. And I want to now look at some applications of that, how we use it, and then move into writing some equations with some information that we're given. So just as a review, here's the slope formula that we talked about. The slope is y2 minus y1 over x2 minus x1. I think it's more helpful to think of it as the difference in y's over or divided by the difference in x's. You can think of the difference in y's as the rise, and the difference in x's as the run. And so then you have the slope being rise over run. So it might help you make sense of this formula, why it actually works. So for example, let's find the slope of the line that contains the points 2, -3, and 5, 6. So if I label this first point as x1 and y1, and the second point as x2 and y2, then I can use the slope formula that we talked about, which remember is y2 minus y1 on top. So y2 is 6 as we've labeled it, minus y1, which is -3. Now notice that since the y value is already negative and the formula has a minus, that I have two minus signs there. Be careful of that. Then it's x2, which is 5, minus x1, which is 2. So the slope then becomes 6 minus -3 is 9. 5 minus 2 is 3. So the slope of the line that contains these points or passes through these points is 3. Okay, another example. A certain line contains the points 3, 2 and -4, 1. What is the equation of the line? All right, so let's look and see how we can do this. The first thing I need to know, no matter what, when I'm writing the equation of a line, I have to know its slope. So if I'm not given the slope, I have to find it. So the first thing I'm going to do is find the slope. So again, I'm going to say this is x1 and y1, and this is going to be x2 and y2. So the slope becomes 1 minus 2 divided by -4 minus 3. So I get 1 minus 2 is -1. -4 minus 3 is -7. And so the slope then is 1/7. Okay, so now I have two options here. I have the slope and I have 2 points on the line because those are given to me in the problem. So what I can use then is I can use the slope-intercept form, which we've learned is y equals mx plus b, and I can plug in what I have. So I'm just going to choose the point 3, 2. So I have a slope of 1/7, and I know that it passes through the point 3, 2. Now you're welcome to use the other point. You should get the same exact result, -4, 1, as you do when you use 3, 2. So this is an x and a y, and I have the slope here, which is m. So if I plug in the m here, and the x and the y value in place of x and y, I can solve for b, which is the y-intercept. So I'm going to do that right here. So y is 2, m is 1/7, x is 3, and then now the equation only has a b missing. I get 2 equals 1/7 times 3 is 3/7 plus b. And then if I subtract 3/7 from both sides to get b by itself, then I get b equals 11/7. So the equation then is y equals 1/7 x, remember the slope was 1/7, plus 11/7, which is the y-intercept. Could write the equation of the line in slope-intercept form. It has a slope of 2 and contains the point -1, -8, and then we're going to graph it. Now, point-slope form, you can see here, as we saw in class, is directly related to the slope formula. In fact, if I divide both sides of this by x minus x1, I get slope equals y minus y over x minus x. So I'm going to plug the numbers in that I have. I'm going to use this as x and y, and this is my m here. So y minus, the y value is -8, and that equals m, which is 2, times x minus, and the x value there is -1. So now it's a matter of simplifying and putting it into slope-intercept form. On the left, I get y plus 8. On the right, this is x plus 1 when I simplify that. So I get 2x plus 2. And lastly, I'm going to subtract 8 from both sides. And so I get y equals 2x minus 6. Okay, now graphing this, I have a y-intercept of -6 and a slope of 2. So I go up 2 over 1, or I can go up 4 over 2. It's the same thing. Up 2 boxes over 1 box. And I get this line, approximately. And you can see that the slope is 2. We made it so. -1, -8 would be right here. And so this is the point that we used, along with a slope of 2, to find the equation of this line, which is y equals 2x minus 6. Okay, now we're going to write the equation of the line in both slope-intercept form. I'm going to use two different methods. Okay, so the first one is using slope-intercept form, which we looked at an example of already. So the first thing I have to have is slope. So slope is equal to, and if I use this as x1 and y1, and this point as x2, y2, then I have the slope is equal to -4 minus 8 divided by 10 minus 5. So -4 minus 8 is -12, and 10 minus 5 is 5. So the slope is -12/5. So the equation of the line then is found by using this slope that I just found and one of the points. I'm going to use 5, 8. So if I use 5, 8, then the y value is 8. So 8 equals -12/5 times the x, which is 5, plus b. And I chose 5, 8 because I knew that I'd be multiplying 12/5 times 5, and those 5s are going to divide. So I get 8 equals, the 5s divide out, so I get -12 plus b, and if I add 12 to both sides, then I get b equals 20. So the equation then is y equals -12/5 x plus 20. Okay, now using point slope form, I've already found the slope is -12/5, so I don't have to reinvent that wheel. And I'm going to choose the point 5, 8. Y minus y1, and if y1 is 8, then I get y minus 8 equals -12/5 times x minus 5. So y minus 8 equals, and here you can see that I have -12/5 times -12/5 times x gives me -12/5 x, and then -12/5 times -5 is similar to what I had over here. That's just going to give me plus 12, and then I just have to add 8 to both sides, and I get y equals -12/5 x plus 20, which matches this one over here on the left. So you get the same thing either way.